Okay, well, welcome back, everyone. We want to tell you about the things that are changing in some of our documents. Next slide, please. There we go. Okay, the Bridge Hydraulics Handbook is our newest edition, just about to come out, we think in June, hopefully. It is by far our most complex handbook to date and covers the whole realm of bridge hydraulics, including pavement deck drainage and tidal issues. We'll see more about that in a moment. We've also changed the drainage manual, the hydrology handbook, storm drain optional pipe, drainage connection permit, and exfiltration system handbook since the last time we talked. The Bridge Hydraulics Handbook covers every aspect. It is in depth. We tried to make it direct enough that it would be reasonably nimble for the experienced practitioner, and so you'll notice when it comes out there's a lot of weedy stuff in the appendices, which are great if you want to drill down into some more technical details. There's example problems. We spent a lot of time looking at this, and as with any new handbook, we certainly welcome people bringing comments, especially errata. I mean, hopefully we caught anything that's wrong, but your comments are very much welcomed. Jen.
And the drainage manual. In the first chapter, we've gone and revised. The revisions are now just shown by the date in the header on the sheet. We had a little bit too many of the vertical bars showing up, and so those were removed just to make the pages a little bit easier to read. In Chapter 3, we've added a new section titled Additional Design Considerations, and in this section we talk about where to place drainage lines with MSE walls and other structures, and additional information on that can also be found in the Storm Drain Handbook. In Chapter 4, Cross-Drain Hydraulics, the permanent facilities has now been divided out to permanent and temporary facilities. In the permanent facilities, we changed the requirement to use ADT to AADT. AADT is more readily available. If it's not available, you are welcome to still use the ADT. The temporary facilities, now instead of just having a standard 10-year design event for your temporary facilities, you now can use the equation at the bottom of the table or look at the table we've provided, and that's for your construction timing. So if you're if your project's relatively short, you can design to a much lower design frequency for your temporary structures. In Chapter 4, we've also removed all of the clearance requirements to the PPM, Volume 1, Section 2.10. So the debris clearance and navigational clearances are now all in the PPM. They are not in the drainage manual. And in the drainage manual, we do reference the PPM just as a reminder if you're looking for that information.
The tidal flow from hurricanes, as most of you know, hurricane rainfall does not look like land-based rainfall. Hurricanes come in bands. It really doesn't follow an SCS type distribution with a single peak. And we had an old reference in there from an historic Corps of Engineers manual. It was not a very good approach. It was the best we could find. What we've added is the option to use a steady state 10-year flow. At the same time, I put out some research that over the next few years that hopefully will come up with a better procedure. The 10-year steady state flow was a kind of a rule of thumb done by coastal engineers, and what little we've looked at it, it appears to be conservative, but it should at least be adequate. A major change in the drainage manual, I think something that's been overdue really. FHWA used to be very adamant about all bridges, even the little low ADT bridges, always had 100-year bridge scour, and we intuitively knew that was a little overkill. Well, this latest edition of HEC 18, which I think they've released, and we have just come out, has the flood frequency and scour design, scour check, flow return periods that you see on your screen. We departed just a little bit from the Fed position. They were allowing Q200 for the check flood. For right now, we're going to keep the Q500 for the check flood for a Q50 hydraulic design until we take a better look at the function of that check flood. But happily, the smaller bridges with the smaller design flood frequency now can be designed for a commensurate level of scour. That is a welcome change from the historical past.
And continuing in Chapter 4, we've also just added some notes about scupper discharge locations. They're kind of common sense. They were in the structure's design guidelines, but scuppers should not be draining onto railroads, travel lanes, shared use paths, or sidewalks if you're allowed to use scuppers at that location. And let's see, in Section 410, we've added a note, median drain culverts. There was a note that the minimum size was a 15-inch, but there may be times when you need to have a minimum of 18 inches, especially like if you don't have a grate over your median drainage system. So that note has been added. And just and the remaining change in Chapter 4 is just kind of, you know, a cleanup. We had an old reference to a backwater requirement that was used to be in Section 4.4. It was just an orphan reference, and that's been removed. In Chapter 5, we've since updating Rule 1486, our language was just a little bit outdated, and so now when for your pond design, we do reference Rule 1486 rather than describing the storm events. And we've also revised the pond freeboard design description, not the 1 foot requirement, but the actual description on how that's measured.
Okay, regarding the optional culverts, polypropylene pipe 50-year has been added to the list of options.
PPP.
PPP, yes. A different PPP than public-private partnerships. We just thought we would let you guess at the acronyms we really mean. We're running out of letters for all of our acronyms. The polypropylene pipe is a little stiffer than polyethylene, a little less stress crack resistant, a little more susceptible to, in fact, significantly more susceptible to oxidation. Right now, it's 50 years. The industry has presented evidence of defensible oxidation protection, antioxidant formulas. We anticipate that will eventually go 100-year, but it will be with more rigorous testing. So that's an option that's come on board. And in discussion with our structures people, we've removed aluminum pipe and added F949 PVC to vertical drain pipe choices. That's kind of a common sense decision. The vertical drains need to be reasonably light, and in cases where the hurricane can come in and bring in salt water, they need to be corrosively inert. Okay, the drainage manual changes that you now see are simply follow-ups from the other things that we told you have changed.
The table 6.1 has been revised.
Yes.
And now on to the handbooks. Our first, again, our first cleanup here was, I think a few years back, NRCS limited the maximum distance for overland flow to 100 feet rather than 300 feet. And so we've just gone and adopted that change, and that change affected the hydrology, drainage connection permit, and the exfiltration handbook. So the examples have been revised to show that new distance. The hydrology handbook now specifically, we've gone through and added the new regression equations. USGS has gone through several year effort to update all of our regression equations. Some of them have changed the flow significantly in your area. There's now 4 zones in Florida rather than 3, not counting the undefined area in South Florida. And we've also added, there's some special local regression equations for West Central Florida, and those have also been added. And all of the appropriate tables and figures to use those equations have been added to the hydrology handbook. Storm drain.
Storm drain. Okay, our geotechs approached us with concerns about pipe leakage in the strap zone, knowing that they need to preserve the shear resistance between the straps and the soil, and that could be a problem if you had some significant leakage. And so you'll see a couple of different drawings where the focus is to try to keep as much of the pipe outside of the strap zone. This one you see now is a trunk line down the center, and yes, the laterals are in the strap zone, but the idea is to minimize the potential problems from leakage. We also have a drawing in there that you'll see, I think it's the last one back, but that's fine, of deep inlets. Deep inlets, there we go, thanks Jen. Deep inlets are preferred over, say, a system where pipes are running through the strap zone. These inlets are stacked and they're kind of put piece by piece, and they're reasonably easy to clean out. The problem is one of the reasons we don't like pipe immediately adjacent to the MSE walls is if there ever is a severe problem, it's very hard to get to them. So these deep inlets can go just very, very deep, as you see. And on the right side there, you see an example of a vertical drain with an elbow at the bottom, typically with a thrust block. That also will minimize pipes in the strap zone. We always use a resilient connector on the bottom there, where the pipe connects to the structure. Settlement is probable, some sort of settlement, and a mudded connection will typically break loose because of differential settlement between the pipe and the structure. So always use a resilient connector on connection between a vertical drain and the structure. Okay. Some changes in optional pipe handbook, right from the previous changes that we spoke about, where table 6-1 is updated, includes polypropylene pipe, and we also transferred that AADT change for jack and bore installations. So these are just follow-throughs from the changes in the drainage manual.
Now for the design standards, we've had 2 major updates this past year. The first is adjustable manholes. These are meant to be used within the roadway. When you want to specify, you need to, on your drainage structure sheets, just construct with adjustable inlet or adjustable manhole top. I believe it's type 1. Yeah, type 1 adjustable is how we're referring to them. It will have the same pay item as the traditional manhole cover. They are meant to match the cross slope of the roadway, and they are also easier to use during construction. We've had a couple test projects and they've gone very well, and the local foundries are pretty excited about being able to offer this to us. We also have a note on corner openings. First, we should try to avoid corner openings whenever possible. When you can't use a round structure and it's inevitable that you have to have this corner opening, a shop drawing will now be required, and it must be approved by the engineer of record. There's a designer note as well as just a general note on this page for this, so please watch those corner openings.
And on the horizon, in fact, this one has already happened. The removal of interim restrictions from HDPE pipe has been enacted as of Monday, I believe it was. And this is the result of years and years, goodness, maybe even a decade worth of testing, where we carefully examined the long-term properties of the polyethylene pipe. And a whole lot of research on this, and so those interim restrictions are removed. The interim restrictions were having to do with under limited access right-of-way, 8-lane sections, adjacent to buildings, things like that. Polyethylene pipe Class 2 will still not be allowed in the Florida Keys due to the heat, to the heat and service conditions. And so on designs coming up, as you're doing optional pipe, the only restriction on the polyethylene, other than the current cover restrictions, should be that it's not used in the Florida Keys. We're also bringing on LRFD pipe cover, structural analysis for LRFD pipe. That was an FHWA requirement that's been in place for a few years, and we're hoping that in 2013, next edition of the standards, you'll see a change in Table 2, Index 205. Probably the minimum cover for the non-concrete pipes, the flexible pipes, will drop a little bit, and the maximum cover will be a little bit higher for the plastic pipes. It will be a different approach. LRFD is a different animal, but we will distill those down into a form on Index 205 where the design engineer can simply look at a table the way he or she does now, and so you won't have to be doing structural computations. It'll still be tabular, but the basis of those tables and perhaps some of the parameters invoked in those tables will change. Okay, I think
well, in LRFD pipe cover, there will also be changes to the culvert service life estimator.
Thank you.
It'll be a pretty extensive change for that, and we'll also be offering training next year on optional materials and LRFD pipe cover.
Right, because even though you'll still be looking at a table, we esteem you as hydraulic engineers that you want to know what you're doing. You want to understand and have some confidence in the basis of what you're doing. So we will be explaining these changes, and you'll hopefully be able to understand where the tables came from.
We'll have a session at the Design Expo also talking about the new Index 205.